All right, kids, here's the final video for Unit 4. Now we're going to talk about special situations for naming. All right, and then we're pretty much done with the unit. All right, so here we go. Lots of practice. Hopefully you've gotten up to this point, and hopefully this will make a little bit of sense. So when we're talking about acids, all right, acids are a type of compound that all have hydrogen plus. In other words, the hydrogen's written first. All right, so it's going to be like H2O, HCl, HSO4, H2SO4, all those different things. All right, so realize that all acids have an H plus. In other words, an H listed first is going to make it an acid. So make sure you guys realize that. Now the golden rule for acids is this. If it normally ends in ide, okay, so the ending, like the second word, like hydrogen chloride. Hydrogen chloride changed to hydro, and then your base word, in other words, not the hydrogen, the other thing that gets bonded with it, and then it's going to be ic acid. So ide changes to hydroic acid, okay? And this is for when you only have two atoms. Okay, so this is for a binary. All right, so this is for a binary compound, meaning that there's only two elements like HCl, HF, things like that. All right, if it normally ends in ate, ATE at the end, ate changes to ic acid. And then if it normally ends in ite, it's going to change to OUS acid. All right, so it's these three rules will help you figure out what you got to do or where it comes from. You got to think backwards, you got to think forwards. All right, so let's go through a couple examples, see if it makes sense. All right, so H2SO4. First of all, I know it's an acid. How do I know? Because the H is first. See how there's two H's? Just as long as there's one H, you're good. So H2SO4. So SO4, normal name, if you look it up in the periodic table, it's sulfate. Okay, so sulfate. Notice, ends in ATE. What's my rule? So normally this is going to be hydrogen sulfate. Now, the rule is, if I have it ends in ate, you change it to ic acid. So now this is going to be sulfuric acid. That's my name. And notice where the change is. It used to be sulfate, now it's sulfuric acid. Ate changes to ic acid. All right, there's your first example. Second one, HF. Notice that for the sulfuric acid, there's three elements. This one only has two. This is a binary acid. So that means it's going to be hydrogen fluoride. All right, HF, hydrogen fluoride. Ide changes to hydroic acid. So I'm going to go hydro, and then it goes to this thing. It's going to be fluoric acid. Hydrofluoric acid. Okay, why didn't you put hydrogen there? Because the acid tells me I have hydrogen first. All right, so anytime I write acid, it's just known that the H is first. All right, so let's try another one here. Oxalic acid, ic. So now we got to think think backwards here. And we have an ic acid. Ic came from ate. So this is actually oxalate. And I know that there's a hydrogen, so I know it's going to be hydrogen. All right, oxalate. Now I look up those two things on the periodic table. I know that because it's an acid, it's always H plus. Oxalate, if you look on your sheet of your periodic table, oxalate's right here. C2O4 with a 2 negative charge. So it's going to be C2O4 with a 2 negative charge. Now, I do my drop and swap. The 2 goes with the H now, and the C2O4, here is my formula for oxalic acid. Drop and swap. Drop the positive negative signs, swap the numbers. Notice the 2 and the 4, they stayed. We didn't change that. Only this charge gets carried over. And this is technically a 1 over here. That gets carried over here, and you don't have to write the ones if you don't want to. All right. Hydroiodic acid. Well, I know it's a binary compound. How do I know that? The hydroic acid tells you that it's going to be a binary compound. So that means I have hydrogen, NH+, and I have iotic is actually iodine. And I know that's a -1 charge. If you look on your periodic table, because it's in group 7, drop and swap. HI. Hi. There's my formula. All right. The more you work with these rules, the easier it gets. I just went through a couple examples. We'll do plenty in class to hopefully get you on the right path. All right. So there's your acid cases. Now let's talk about another special case, which are called hydrates. What is a hydrate? A hydrate is when you have water molecules attached to a compound. All right. So for example, it didn't get completely dehydrated. In other words, all the water didn't evaporate off. All right. And it's really just the normal formula writing we've been doing. All right. So if we look at this one, this is how these formulas are going to look. They are going to say times, however many water molecules. So first thing you got to do, name this MgCl. Well, I know Mg is magnesium. Magnesium. And I know Cl is chlorine. Remember, it's not chlorine, it's chloride. All right. And then I have water. And how do I tell me? I have 5 waters. What's the prefix for 5? Pent. Okay, so it's penta. And then it's going to be hydrate. So penta means 5. Hydrate means water. Remember hydration reaction or hydrate when you do a hydration reaction in biology. Magnesium, chloride, pentahydrate. There you go. All right, now let's do the other way. Whoops, misprint. This should be di. All right, lithium acetate dihydride. Well, I know lithium is a +1 charge. Acetate is not on your periodic table, but it is on your polyatomic list here. So if I look at my polyatomic list, what do we have? Acetate? Yes, we do. Acetate's right here. Acetate, and here's my formula, C2H3O2, -1 charge. So I write it down here just so for safekeeping. C2H3O2, -1 charge. So I drop and swap plus sign and negative sign, drop the charges, swap the numbers, C2H3O2. So there's my lithium acetate. And then to tell me how much water is attached to it, I put a little times sign there, something like that, a little dot usually works. Dihydrate, well, di is 2, and hydrate means water. Lithium acetate dihydrate. All right, so there is your final special case naming. We'll be doing a lot of practice ones in class. So these are just the basics. So make sure you understand these basics, and it will help you out a ton when we do the things in class. So hopefully these videos helped. We'll talk to you guys soon. Have a good one.